In next few minutes you will learn from basic to advanced techniques for using buttons. I will explain why you should always avoid delay function in your code and help you create first interactive device, reaction tester. Using buttons is the oldest way to interact with electronics, and while in other devices they mostly work like switches, the ESP opens up countless possibilities to utilize them. The whole device can be controlled with a single button by detecting clicks, double clicks, sequences, long presses, etc. Moreover, the ESP can also be controlled with virtual buttons using its inbuilt Wi-Fi feature. As being said, in most cases button acts like a simple switch. When pressed, the two parts are connected, allowing electricity to flow through the circuit. So, in theory, we can set ESP pin mode to input and receive high signals when button pressed. But there is one problem I want to show you. Let's check our assumption. I'm defining constant for built-in LED and button, and then setting pin modes. When we receive high signal on button pin, we'll turn on LED. The wiring diagram is straightforward. I'm connecting one LED button to the pin and another to 3.3 volt. At first, it seems like everything works fine, but look closely. After releasing the button, the LED stays on for a while. This happens because the pin is essentially floating, meaning it has no defined logical level. As a result, electrical noise can randomly change its state. To resolve this issue, we need to explicitly define the pin's default state. There are two ways to do this. One option is to add a resistor between pin and ground, but that's definitely not the best way because adding a resistor for each button can be pretty annoying. Fortunately, there is another way. The ESP has inbuilt pull-up resistors that work the same way. You can enable them by setting pin mode as input pull-up in your code. But in this case you need to connect button to ground and invert the signal because button will be in low state while pressed. We have covered the basic button usage, so let's add a more advanced feature. I want to toggle the LED state by pressing the button. To achieve this, we need to track the button previous state. If button was in low state and now become high, it means the button was pressed. On the other hand, if it was high and become low, it means button was released. I want to toggle LED on release, so I'm updating LED state with digital write command. Lastly, I'm updating button previous state after each loop iteration. Let's check how it works. Have you noticed this inconsistent behavior? The reason hidden in button nature. It's a mechanical device, and depends on its quality, contact which connects pins can bounce for a small period of time. As a result, ESP detects this bounce as extra clicks. You can't get rid of such bouncing, especially with cheap or old buttons, but you can handle it in code. The only thing we need, add some delay and don't read button states while it's bouncing. But remember, at the beginning of the video I've told you that you shouldn't use delay function. The point is that delay is blocking function. It means the loop execution freeze and ESP do nothing until delay ends. While it's not critical in our example, imagine how painful lose some data from sensor or lose control from drone because you pressed the button. And fortunately, the solution exists. Let's start by defining a variable to store the time when the button starts bouncing. We can set this time using millis function, which returns the number of milliseconds since the ESP board starts running. The logic related to our button should be executed only after we confirm that bouncing has stopped. But how can we know when to start debouncing? Actually, it's a moment when the button changed state for the first time. Additionally, I check that the timer hasn't been set, and I reset it afterward. All we have left to do is compare the current time with the timestamp we saved and check if 50 milliseconds have already passed. This number comes from practical experience with button I use. It can be increased if side effects still occur. And don't worry, you won't miss real clicks because it's impossible to toggle a button faster than 1 or 200 milliseconds. Before we continue, I recommend pausing the video and taking time to fully understand the current code, as it's a crucial concept. Even better, try write this code by yourself. And don't forget to press like and subscribe so you won't miss future lessons. The system works as expected. However, you may notice that we wrote a lot of code. If we add another button, the code will be doubled. To avoid this, I'll show you how to encapsulate logic in future lessons, but for now, let's check some existing solutions. Click the Platform I/O icon and open Libraries from the Quick Access tab. Here you'll find plenty of pre-existing solutions, so you don't need to reinvent the wheel. Type a keyword related to what you're looking for in search bar, and let's try the first library. Click the Add to Project button and select your project. This will add the dependency to the platform.ini file. I won't waste your time, so feel free to explore the examples and documentation to learn how to work with new library. Let's put all our new knowledge together and build our first interactive application. The idea is simple. To activate the device, press and hold the button for more than 1 second. The LED should start blinking. Once you release the button, the LED will turn off and ESP will generate a random time interval between 1 and 3 seconds. When the current time reaches the generated interval, the LED will turn on. Your goal is to press the button as fast as possible. The ESP will record your reaction time. If you press too early, you'll have to start over by reactivating the device. Try to pause the video and write your program by yourself. Then share your best reaction time in the comments. If you want to see the solution first, I'll explain it right now. First, I defined a bunch of constants for LED blinking frequency, long press detection, random time generation, button debouncing time. Along with the button itself, I also need to store some variables. A flag to detect the button is pressed, a timestamp to track the LED change state, and a target time to measure the reaction. Inside setup function, I registered all the necessary button events and configured its behavior. Inside the loop function, I have a condition that blinks the LED when the button is pressed. The flag is set inside one of the button callbacks. I wrote the blink function in a similar way how we handled debouncing. It checks if a certain amount of time has passed since the last state change and updates the LED accordingly. Once the button is released, I update the state and calculate the target timestamp. Based on this timestamp, I configure when the LED should turn on in the loop function. Inside the click callback, I calculate the reaction time. I also extracted the bounce time to get a more accurate result. Finally, I display the result based on the time difference. And that's it. Try it out, tweak the timing and let me know your best reaction time in the comments. And don't forget to like and subscribe so you don't miss future lessons.